Fantastic. It's another shiny, bright, sunny day here in Detroit area. So I'm glad that at least the day is looking more prettier.
Yeah, beautiful day today.
How have you been doing, Ben? It's been a long time we have been talking.
Yeah, no, I'm doing well. We've managed, with a high schooler in the house and a college student that got sent home. We've been fighting over bandwidth, right, during the day.
I think we all are fighting on the back. And so I'm glad our kids means it's always a tussle to see and balance that. First of all, thank you for your time to jump over here and just talk about more from your world of what's happening, and it'll be great to see and go through that. But before we go over there, I just want to ask. I'm going to ask random questions to every speaker. So first of the random questions to you would be, what are some of the things that you learned about yourself in this last year of COVID? Because everybody went and got disturbed by this. What was the thing that you loved or cherished or saw that for yourself happening?
Well, I'll start with, I think I confirmed, I don't mind remote working. It can be actually very effective, right? So if you're doing, depends on what kind of work you're doing. When I'm doing creative or planning type work, I like to be with people in front of a whiteboard. So that's been challenging. If I'm doing refining or execution work, fewer people disturb me in this office than they do at my real office. So what I did absolutely confirm, and we've gone back on a partial hybrid schedule. So I was actually in the office yesterday, a couple days a week, try to keep the building density below 50%. But I'm a walker and a talker. I like to get out to the labs, interact with people in their space and talk to people. And I always knew that, and it was sort of part of my everyday approach to all different types of work I do. But that being taken away over the past year, or really being significantly cut back for about 10 months, was very impactful for me. And so it made me really value the human interaction. All the things we take for granted when you see somebody in the hallway and grab and say, hey, you sketch an idea and say, what do you think about this? You can do it, online for sure. There's great tools like Mural, and, we use Teams, and it's been extremely effective. But I would say that was reinforced for me personally, how important it is to have human to human interaction, and just the way my brain works and how I like to come to work every day.
That's pretty fantastic. I think I also can second the first thing you mentioned about it depends on the work, the type of the work you do, but working from the home sometimes get more work done, and we are all saving a lot of time in just random commuting. Traveling is good. I like driving, but commuting, it becomes itself a big kind of a time drain. So that's nice.
The other challenge working from home is you really need to be careful what snacks are in the pantry. Yes. No more Oreos or Doritos in this household, I'll tell you that.
I will tell you, the pantry door from here is only 10-15 feet, and I think these houses should come with a lock on the pantry. I always talk about that, but I have not yet installed it because of this other reason. But man, that adds lots of pounds. So I think most of our audience knows about you. You are right now the CTO and the senior VP at Cooper Tires. Before that, you were at Tenneco. Before that, you had an illustrious career at GE as such. But what do you do for fun? Well, let's know a little bit more about Ben. What do you do in your free time?
Well, very much like Thomas, my family is sort of the center of my orbit. It's harder and harder with the kids getting older to keep them interested in doing things as a family. But we're very much an outdoor family as well. Try to get out on bikes, hikes. We like to travel a lot. That's been another thing that's been challenging. We have a lot of pent up kind of desire to get back to some of the travel routine we had. I like to do a lot of yoga. It's helpful for me, both from a fitness standpoint and just, I like to wake up early Saturday mornings, and as the light comes up, it's very calming for me. I have a great group in Ann Arbor that I practice with, and we've kept the practice alive using Zoom. So it's been good. And, I just, again, I like to interact with folks. So I'm very much in the community. That's pretty much it. Other than work, it's pretty much beautiful. Trying to stay active.
That's beautiful. Yoga is pretty interesting. It's not easy. It's you have to apply yourself to it, and I'm glad you're pursuing that art. It's a performing art in a way. It depends on how you see it. Awesome. So I think you have some prepared slides for us, so we can.
I do. I just a handful, and I just wanted to set the context. But I was really enjoyed Thomas's presentation, and I like to look at things as a system. And when you think about these two talks even being back to back, a tire, which I think most of us take for granted, and I did before I started working at Cooper, is a highly engineered performance material. I'm going to show you a little bit of a breakdown of that. But when you really think about the entire user experience and mobility, it starts with that tire patch at the road, and it sort of ends with your gluteus maximus in the seat, right? And think about it at a system level. You go from a tire and a wheel to your suspension, all the way up to how are you interacting with the vehicle, which is the seating. So when you think about advanced systems and how we're going to influence, regardless of when mobility changes and when the vehicle is used differently than it is today, thinking about all of these as a full systems engineering approach and not just trying to optimize components or subsystems is sort of where I like to pick up the problem. And so, it's interesting, in my previous role before Cooper at Tenneco, where they had a suspension business, I was out talking to other players to try to develop this ecosystem from a product design standpoint as a suspension supplier. And I was out, my last sort of stop on the route was to try to find a tire partner. And now I've joined a tire company, and I'm kind of flipping the script. But it's been a remarkable, I've only been at Cooper for about a year and a half. It's been a remarkable learning experience because there's just so much happening in a tire that I never really realized. And so I'd like to just spend, maybe 10 minutes with what I call a little bit of 101 stuff, just so everybody can wrap their head around it. And then I hope we get a series of questions, because as this entire mobility set of megatrends plays out, tires are right at the center of all of that. So whether we want to talk about them from the dimension of case or anything else, sustainability, tires have a critical role to play, and they are going to be along for the ride. And I think actually take a seat at the front of a table, because they're so impactful in terms of how they impact the user experience. So I am a Teams guy, so I'm going to click on share screen and.
Yep. And then that.
Let's see if here we go. Okay. So again, I just had a couple pages here.
Take your time. Don't worry. Don't hurry. It will be really interesting to see the nuts and bolts of what we take and assume. So, and I'm looking forward for this.
Great. So I as GVAC said, we hadn't spoken in a while, probably over a year, I think, last time we talked. And very recently, Cooper, with one of our new snow tires, was awarded this design prize from, I think, the Chicago Atheneum Museum of Architecture and Design.
Nice.
And so I took the opportunity to ping GVAC to just say, hey, tires can be beautiful too, right?
Yep.
No one ever thinks of them. We all think of them as black donuts, right? I was actually very surprised. And when I looked at what was submitted, anything could have been submitted. And so I was actually very excited that we won this award. This is a wonderful product that was just developed. That's me in that Jeep last winter, test driving these things up at a test track in Canada. And, this idea that not just from a design in terms of aesthetics, but I sort of pick up design from a functional design standpoint, right? And features and benefits, and what are the integral elements from an engineering standpoint or a material science standpoint? How do those feed what I call functional design? It's sort of where I pick up the problem. So anyhow, I felt there's not too many opportunities where I get to send GVAC something and say, hey, we won an award in design. I never thought the first one would be a tire, but here you go. So again, I just wanted to touch on a few things. And the first thing, I suspect many people take their tires for granted. And when you think about being on the highway at 75 miles an hour with your family, our purpose statement at Cooper is really built around the word confidence. And I think the reason a lot of people can take their tires for granted is there's a certain level of confidence, even though they don't understand what's involved in designing or manufacturing the product. We end up in this situation where, in fact, many people are abusing the product. They drive around on underinflated tires, for instance. Very common. I mean, it's not a common habit for folks to check their tire pressure. And not as only is that a good thing to do on a regular basis for fuel economy, it's a good thing to always be looking at your tires, because again, that's what's in contact with the road as you're maneuvering your vehicle around. But when you think about, you know, what's beyond that road contact, my background is in chemistry. I'm a chemistry materials person, and you know, when the material science and the chemistry that's involved, not just in the tread compound, which is very important, but in the sidewall, all the different rubbers. I mean, tires are, as I'll show you in a page here or two, you know, this can be 15, 17 unique components that come together before the final product is vulcanized. Each one of those components can be a combination of another dozen or so ingredients. And so when you think about rubbers, different types of rubbers, both synthetic and natural, you think about textiles, right? Nylon, polyesters, steel, all of this coming together from an industrial standpoint, very, very interesting problem statement. And the opportunity to not only improve performance, but, you know, experiment in that material space. It's very, very interesting space. And then ultimately, when you get down to design, I suspect the reason we won that award from the Athenaeum, it's the most visible thing you see is in the tread pattern, right? And so when you think about it, and I hope after today's presentation, you all take a close look at the treads on your car, regardless of whose tires you buy. What people, again, don't really think about very often is that contact patch that's highlighted here on these two different tires is about the size of the palm of your hand. So think about that for a second. You could be driving a large SUV down the road, and at any given moment, there are just 4 spots where the whole vehicle, 3,000 pounds, whatever it is making contact with the road with those 4 palm-sized points of contact, those 4 contact patches. And so in ideal conditions versus non-ideal conditions, you know, there's a lot to be considered. And it all starts with that tread design. And again, something you probably don't think about a lot until you're in this space, but there is a lot of both engineering and what I would call art in that tread design. If you think about all-terrain products, you know, folks who like to put their really beefy tires on their Jeeps and go off-roading, for that constituency in the market, tires are like almost like jewelry. There's a bling effect they want on their tires. They want them to be beefy. They want the tread look a certain way. They want the sidewall to look a certain way. So all of those features, although they're providing functional elements to the performance of the tire, can also take on a very elegant sort of cosmetic aspect to the product. And again, it just depends on the segment of the market and who's interested in that. But there's a very large tire constituency at SEMA, for instance, right? So those folks who go out to the aftermarket event in Vegas when it comes back, or when it's been in the past, see lots of different tire players out there, because the aftermarket and kind of enthusiast market that represents SEMA, very, very interested in the aesthetics of the product. Wanted to just take a moment. I always like to learn something in every talk I participate in, and so I also like to teach something. If you take away only one thing today, I want you to take away how to read your sidewall, right? So we all take this for granted. We sort of know the size of our tires when we need to replace tires. But if you haven't done it, take a close look at what's on the sidewall. There's an enormous amount of information. So let's start with what's in orange there, right? The big number that you probably know when you go to buy or replace tires. What is that in this example, 215/60R16 mean? Well, that 215 stands for 215 millimeters, and that is the width, that section width on the left. That's the entire width of the tire. So the bigger that number is, basically the wider the tire is. That 60 represents what is called that section height. So that aspect ratio is represented there. So when you see tires that are very, very low profile, that number is getting smaller. And you see tires that are very high profile, that number gets to be bigger. And then the R16 is the rim diameter. right? And so the trend in the wheel and tire game these days is bigger, bigger, bigger rim diameter. So 18, what used to be normal, 15, 16, 17 is now going out of sort of vogue, and the 18s, 19s, 20 and above are starting to become much, much more common. So I won't go through all the other stuff on the sidewall, but G-Back, I assume that these pages will be made available to folks. Just do yourself a favor when, one time when you got a few minutes, and just take a quick read around the rim. A lot of interesting information there, including when was that tire made, right? What week of what year was it made? What load rating does it have? What speed rating does it have? A lot of things that, unless you're sort of a nerd around these things, or you don't necessarily study, but is actually very, very useful information for how you think about you use your vehicle and what are you willing to pay for, right?
And this sounds pretty interesting, because I should actually give the assignment to both my kids to go around and find those numbers for me, because it would be interesting treasure hunt for them to see so much information right in front of us, right? Means, and we take it for granted.
Well, and it's a lot of times it's the white walls are not a thing that's very popular today. So a lot of times it's sort of it's embedded in there, but people have to you have to kind of get down and look for it.
You have to get down and look for it.
But it is again another surface here, the sidewall, from a design standpoint. It's a very interesting space. I think in the future, not too distant in the future, what's going to happen on the sidewall and the way the tire and the wheel look, given sort of future designs coming at the top hat level, it is a remarkable space for innovation, remarkable space. So it won't always look like black donuts, is my prediction. I wanted to just touch on one thing, and I'm going to ask Lene to show a very short video in a moment. Tire manufacturing environments, like many industrial environments, are usually pretty off limits. A lot of proprietary trade secret stuff going on in a tire factory. So I can't show you an actual video of an entire production line, but what I did want to show here, and this is a public video from a supplier that produces, and I'll walk us through this when the video's on, produces automated equipment. And so what I want you to take away from this is to realize that what the state of the art looks like in an industrial environment here is as a high tech and as automated as anything you will ever see. And the reason I think that's important is, and I wanted to show it today, because I'm a huge believer in, as you're designing and developing a new product, at the same time, you need to be thinking about your manufacturing processes, right? Because very often these things get very disconnected. And at the end of the day, when you have a factory that's making 40, 50, 60,000 tires a day in 3 shifts, you need to make sure that the innovation and the investments you're making up front in your product development can actually be realized at scale, on cost, on time, at quality, right? And so, again, not something you probably see every day. So Lene, why don't you go ahead and click the video, and I'll walk us through this a second. So this is what's called a single stage tire building station. What you're going to see here, we'll watch a couple loops. There is what is the portion which is the carcass getting inflated by a bladder. It's now going into here. This is all still soft. There's the belt package that was just put on. Again, it's under pressure. It's now going to go down the line, and it's on its way to being cured, right? So here's the start. It's the inner liner. You have now the carcass. Moving to this next station where the bead for the rim was just put on there, if you didn't see that. And then here we go with the belt package and tread compound. So that's enough, Lene, because it's just going to repeat itself. And the only reason I wanted you to see that was, again, I think when we think about product development, design, a lot of the things that many of us work on what I call the front end of the funnel, it's really, really important to understand what is ultimately going to happen on the shop floor, and what design features or functional features and benefits are we adding in order to delight the consumer. They also have to be manufacturable. And a lot of times, especially when we get caught up in a lot of the future, where a lot of concepts are developed in order to encourage people to ideate and really, come up with new. I just want to make sure that everybody's always reminded how important it is to think about at some point, we need to be able to manufacture this at scale. And the earlier you start thinking about that, I think it is better for everybody. And actually, I think creates a lot of opportunity for innovation around the process as well. So that was the total of prepared material I had. The conversation here is very open. I think, Vivek, I wanted to talk a little bit about how tires are moving in terms of some of the vectors of these mega trends. Certainly sustainability is a big topic in this industry. It's unfortunate that tires are not today a very sustainable product. The thermodynamics are not in your favor if you try to, de-cross-link and actually try to recover starting materials. So you have to find second life use. And then the sheer number of tires that are discarded every year on this planet is massive. And so there's a lot of opportunity there because the current use of an old tire that's not landfilled and somebody's burning it for low quality enthalpy, probably in the cement industry, that is not a great outcome for anybody. So there's a huge opportunity on the sustainability front as well.
Absolutely. I mean, it's sustainability, and we can talk about that a little bit more later. But I think this is the element of understanding this everyday ubiquitous element that's around us, and it's in a way invisible. We don't see it unless somebody like us points us to look at that direction. It makes sense to see how it is ingrained with whatever we do. I mean, it's just like shoes, right? I mean, these are the foundations of what we do, and as you said, just a palm-sized area, 4 of them across the vehicle, and that's how we use it in rain, snow, and put our not lives, but it's basically the entire vehicle.
You know what one of my favorite quotes is? Sorry to interrupt.
No,
never be cheap when buying shoes, tires, or mattresses.
I like that, and it helps the.
And if you think about it for a moment, exactly the point you were making. You spend a lot of time in your shoes, you spend a lot of time in your car, and you spend a lot of time sleeping. So it's not a place where you want to go cheap.
Absolutely not, because you're spending a lot of time there. The foundations of what you do means if you're going for hiking, a hiking pair of boots is a perfect necessity, and at the end you will still be refreshed. And the same thing for mattresses too. 8 hours at least minimum recommended to be over there. But that's pretty interesting. But then, as you said about the process of innovation or invention, trying to understand the economies of scale at the end is really really crucial to see how these smaller changes, because a small change in the upfront system or the spearhead of the design system can cast a shadow, a ugly shadow or a good halo on whatever you are doing down the timeline. So that is really crucial as such. We talk about the tires, but from your perspective, the world of commercial tires for fleet vehicles and how they are to be used versus the use of passenger tires like you and me. How should we look at the differences in those as such?
There's a lot of commonality. I mean, there's difference. I mean, let's take a Class 8 truck, right? I mean, there's different tires, whether they're steer tires, whether they're trailer tires. So from a functionality standpoint, the design is different, the material selection is different, but a lot of what applies in sort of your design principles, your engineering principles, applies equally, whether it's commercial or passenger car. What I will say about commercial trucks in general, and the whole fleet model that drives a lot of those businesses, because they're fundamentally driven by total cost of ownership models, the business cases are, it's a great place to introduce new technology, because at some point it's the payback that is the basis of the decision making. It's not the price point or first price, right? So if we can develop new tread compositions that ultimately reduce rolling resistance, somebody who owns a large fleet of trucks running back and forth between Long Beach and New Jersey, they know how to dollarize that very, very, very easily, because that rolling resistance is a proxy for fuel economy, right? And ultimately for their emissions. So in Europe, very, very important, they can take credit for these things. So I think that when you think about advanced technologies, there's a lot of talk these days about use of sensors.
Yeah.
Right. Sensors they're already making their way into tires. Right. So from a distribution standpoint, people are talking about using RFID tags. But if you actually think about a future state where you could not only measure tire pressure, right, which you want to be at optimal tire pressure if you're running a fleet, but you could predict asymmetric wear on your tread. So from a preventive maintenance standpoint, all of this could be measured real time. All of this could be data managed from a logistics standpoint. Very, very powerful use cases in commercial fleet applications. I believe, for instance, when those types of sensors are mass used, it's going to start in the commercial vehicle space first to prove out the value, prove out the use case. Personal use vehicles today, passenger vehicles, are still so much of the purchasing decision for a tire is based on price, right? It is likely the most expensive replacement part on your vehicle.
It is.
I mean, it's not hard to spend $1,000 replacing your tires, right? So I think the average person, that is a tremendous amount of money. And if they can save $200, it's a big influence on them. They don't necessarily spend the time to go to Tire Rack or go to Consumer Reports and really look at this. Is this one better or worse on wet traction or snow? They might be influenced just simply by the fact that they can get a $200 discount on that product that day.
Yep.
So you really need to be able to demonstrate a benefit that they can understand, that if there's a premium to be paid, an incremental cost that generates an increase in the price, that the end consumer really values that and is willing to pay for it, because they're not operating on a total cost of ownership very often. They're operating on a first price.
How do you
So
make?
I'm sorry, go ahead.
So how do you make this kind of an end user appreciate the amount of technology that's in all this siping and threadwares and all those things? Because it is still, as you said, it looks like it's still a technical product, right?
I think to some extent it's user based. I mean, a lot of people still don't put winter tires on their car, like buy all season tires. And the trend in Europe right now is moving towards all season. They've been very winter summer, and that those markets are shrinking and all season is taking off, right? Sometimes that's the right answer for an individual. I put winter tires on my daughter's car, for instance. I don't put them on my car. Probably a bad habit. I probably should, but when she first got her license and she first got her first car, it was worth it to me to put winter tires on her vehicle, just for that added safety and maybe even just for my own added peace of mind. So I think a lot of times the feature and benefit package, there's certainly some opportunity to educate and to simplify things. I mean, a typical tire engineer will try to draw you a spider web that has 15 corners on it. They're trying to make trade-offs and optimize this feature versus that feature. We all know that's not how consumers think, right? They want to know one or two or three most important things to them. And so I think there's a huge education opportunity for sure. But when I zoom out again and I ask myself, okay, as you get to common platforms, fewer common platforms, where the top hats may change, but a lot of what's underneath is going to be commonized. Tires have a similar role to play. If you stop thinking about the tire discretely and start thinking at a systems level, and what experience, whether it's a comfort or handling experience, are you trying to deliver to the passenger, and start thinking about how you can partition, essentially distribute those functional requirements differently if you think at a system level. There's a lot of design opportunity in tires. And when we finally get to that level 4, level 5 autonomous world, I really believe the big opportunity is going to be so much of a tire today is designed around as much subjective as objective functionality. And even as tires are evaluated, at the end of the day, it's drivers on test tracks evaluating them, setting those ratings. When we move to that world where it's no longer a foot on the brake and the gas, it's no longer a human experiencing those subjective inputs, it's going to completely change the design space for a tire, because you're no longer going to have to design to those requirements. The way, at least the balance will change is what I guess I would look at.
That's a pretty important point, because when really we go to, and we're waiting for that autonomous shift to happen, then you don't need to design for the human user interface, the human-centric design. It will be machine-to-machine centric design, and that will be pretty.
Yeah.
If that causes or that actually helps us in getting a little bit more of sustainability principles inside it, because we might not need it for the human consumption. That should be pretty interesting time to see what can be done. That's
yeah. And as all the subsystems on the vehicle are going to go through this transformation of what do they need to deliver in the future based on future, consumer needs, how the vehicle is used. Again, back to this future world of level 4, level 5. But so much of the vehicle today is the investment is around the costs associated with crash safety, right? What happens in a world where, if you believe the models, we'll have fewer accidents because the human induced accidents will go down or away. And you start moving to composites versus steel. You start doing lots of different things at the vehicle level. Again, what implications does that have all the way down through the subsystems, all the way down to the tire? And if you start thinking about those at a systems level, how can you, again, make trade-offs in that world that today you couldn't make? I think that's what's going to be the most exciting thing. If you're an engineer and a designer on these types of products in the next 20 years, I think it's going to be a very, very interesting time.
That will be. I'm really now pretty intriguing thought of design for a machine versus, as let's say, design studio. We always think about humanity-centered, human-centric, and there will be elements where we have to think about the possibilities of what other design intervention can happen, where we don't need to think from that perspective. Even the world of steering wheels too, right? Sometimes steering wheels are designed to make sure we get the feel of the road. And now, if there's not going to be one, we are not going to be thinking about those elements. Coming back to the earlier point, we were mentioning about the sensorification, right? In the connectivity and autonomous way of the world, how are the tires and the sensors between them going to play with the V2X infrastructure and architecture? That's an important kind of a connectivity point.
I think that absolutely will be the case. There's still a lot of work to robustly industrialize these sensors. But if you, again, fast forward to that future world where you've got an infrastructure that can read and transmit data, think about that tire is your best sensor. That tire in combination with your suspension system is itself a sensor. Think about an instance where we've all experienced this. We've walked on the brakes and we've hit black ice, right? And then your heart rate shoots up and you panic. We all, unfortunately, from time to time see on the news where that happens on a freeway and 50 or 100 cars pile up. In a future world where that tire, that is your first opportunity to experience that change of coefficient of friction going from the asphalt to the ice, that signal, which can now be measured, can be transmitted through a V2X network, so that probably car number 1 is still going to have some challenges, but car number 2, 3, 4, 5, 6, all the way back through those pileups, is now going to get data sent to it that it's going to allow the systems, braking and steering systems, to do something, make a decision a fraction of a second earlier than they are able to do today, because today it's a human. And in many cases there's fog and there's other reasons why there's no decision taken. So if you think about that, how important a tire is, because until we're all moving around in the human drone, no matter whatever else changes, these things have got to touch the road, right?
Yep.
And so if you think about it like that, where could a tire go? Again, as part of a bigger system on the vehicle, I look at it as part of an overall sensing capability that has not today been exploited.
and hopefully we should be able to explore it more and more for the benefit for everybody. So from I think from the world of ICE vehicles, or now coming the newer wave of the EV vehicles, this packages itself will demand different things from the way the compounding or the tires will be designed.
Absolutely. I mean, you're going to have there's continuous innovation going on around on the material science front, right? So changing, back to rolling resistance, right? So the trend is lower and lower and lower rolling resistance, all in service of better fuel economy, especially for electric vehicles, right? If you want to realize the range promise of the battery, you need to have optimal rolling resistance. So that's lots of different contributors on the tire, aerodynamics, other design features. But at the end of the day, the most impactful one is what tread compound, what is the chemistry and the material science in the tread compound, and how is that impacting the overall rolling resistance of the tire? That is by far the biggest impact on this parameter. So I think, yeah, there's just a lot. There's no end in sight on the material side. No end in sight.
And just for the audience, for you might already know this, but for all the reasons, you're the right person to talk about this. You actually have the PhD in chemistry from Yale University just in that. So the compounding is going to be really, really important. And I think that just ignites the thought. I think you mentioned, or can you talk a little bit more about this sustainability perspective, but more about this microplastics and the elements that are coming into our river and water bodies? Can you step back a little bit and let people know how to think about that going forward as a citizen of this world?
Sure. I mean, again, it's a big challenge, right? And so one of the one of the consequences of all the millions of miles that we all drive around every year collectively, as your treads are wearing, right? You get 10, 20, 30, 40,000 miles and your tread starts to wear down. Well, all of that material is going somewhere, right? It's not vanishing. What's happening is those microparticles of your tread are essentially ending up in wastewater. Because what's happening is they're getting ground up and they're falling to the side of the road, they get rained on, and they end up in tributaries and ultimately into rivers and into our water. And so what has been happening over the last many years is a lot of science around this, a lot of different organizations studying this, because it's another form of pollution. And ultimately is where it's at today is those tire road wear particles, as they're called, are starting to get treated kind of in the same category as microplastics.
Wow.
And I'm sure everybody listening today has heard a lot about microplastics in the last 5 years, and what that's doing in terms of how they're ending up in fish and a lot of other places where we don't want to have plastic in the water. So it's a huge challenge, because it's one of these things that at scale, think about all the millions, 300 million vehicles running around on the roads in the US today. It's not something that somebody can just innovate and flip a light switch. And so it's a big challenge, and getting more attention, going to only get more attention, an area that is likely over time to maybe be regulated, no different than tailpipe emissions are regulated. But it's something that impacts all of us because, again, it's part of the environment. And so we need to think carefully about these types of problems that exist on some of these everyday products, again, that we don't think a lot about, because ultimately it's just exacerbating some of the challenges we have from an environmental standpoint.
And that means I'm glad at least hopefully the experts are looking at this, but that is pretty scary thing to see about the number of years we have tires on the market, like literally starting more than 100 years ago. And we are new vehicles or old vehicles, tires are just going to be added and added and added, and it's happening everywhere, every country, and the things are spiking high up. It's good for the tire industry business world, but the amount of microplastics accumulating in streams and salmons and here and there, it's a pretty
well where it's ending up. And there was recently some articles that were published, actually one in the journal Science, so it got a lot of attention. Some academics out on the West Coast in the Seattle area, I believe, started studying exactly what is happening to salmon in certain parts of where, where people fish commercially. And what they were able to determine was some of the chemicals that were found in these salmon were directly coming from the tire industry.
Wow.
So again, I said this earlier, a tire has about 100, you look at the bill of material, by the time you get done with it, it has about 100, 120 different components in it. A lot of different oils, antioxidants, different binders. Some have transition metals in them. A lot of different things that you just don't realize because you don't see, but they're ultimately in the product. And they've been in the product for many, 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 many years. What people are now finding out is some of those things, some of those chemicals, when they get into the wrong place, are having very, very unfortunate consequences. And when you look at how big of an industry commercial fishing is, specifically how important salmon fishing is to the Pacific Northwest, you now start to have people that say, wait a minute, what's going on here? What are we going to do differently going forward so that this, not only this problem, but other problems that have not been identified yet can be addressed all the way back up at the design and material selection point in the product development process. And there is probably not a tire company in the world that is not carefully studying this, because it's very, very impactful, not just to the environment, but to their business.
Yeah, that's a completely different point, and it makes stewards of what's happening and how we have to think about. I mean, some of these things were maybe not done intentionally, but we are just doing it. And then on the hindsight, we realize like, oh my God, we are not doing this. It might be even the same chemicals we might be using on lawns, or the things which might get highlighted after a couple of decades. So it's I think that's the way people think about evolution, at least the progression of civilization. But you never know what's really happening, and catching you up from different perspectives. Try to change gears here a little bit. I think, can we talk about a tire as a purchase commodity versus tire as a service model? I think that's a completely different kind of an thought process.
Sure,
Right?
sure. I think it's a good point. So there's a lot of discussion in many industries about businesses converting to service-based models, and some of the folks here today might have seen some activity from different companies where, very similar to where you can have your windshield changed in your driveway, right? Safe Light, very common company, I believe they're owned by Allstate, will come to your driveway. I've done it. It's great service. And within 2 hours and you're parked in your own garage, they'll change your windshield. The same models are starting to pop up in the opportunity to have your tires changed in your own driveway.
Wow.
And that's not brand new. It's people have been experimenting with that at sort of the small scale for a few years. But if you extend that out where this could go, and some OEMs were experimenting with this over the last few years, even at the vehicle level, instead of buying the product, you just subscribe to a service. So would you pay X dollars a month if I was to guarantee you that during all seasons, you would have the right tire on your vehicle, and it would have the right tread depth, i.e. it was not worn out, and any problems you had didn't cost you anything incremental because it was a service-based model? And so you can imagine tires someday going in that same direction, right? Because again, today we discreetly go out and buy a new set of tires, spend anywhere from $600, $800, $1,000, $1,200, depending on what we buy. We might do that every 2 to 3 years, depending on how much we drive. So you're spending a substantial amount of money on, again, what I think is the most expensive replacement part on the vehicle. So if you took that same amount of money and said, okay, what would you sign up for this service? And you didn't have to do anything. You didn't have to go make an appointment to put your winter tires on. You didn't have to go anywhere. It all happened right in your driveway. And all you do is pay X dollars a month for the service. And it's sort of, you're buying tires by the mile or tires by the hour, or however you want to think about the business model. I could see that. It's something it's possible.
I would say yes to that. That sounds pretty interesting. I mean, if they can add a little bit more services to it, or fuel my vehicle in my driveway. I do not know whether the insurance will be high enough for that or not. But yeah, every weekend a truck will come and just fuel the vehicle, do this tire thing is of detail the vehicle, and off you go. And that's not that I'm saying that I'm lazy, but the convenience part is pretty amazing.
Yeah, there's a lot of value associated with time, right? So the convenience, not having to think about it, these would all be part of the business case.
And it's happening in other parts of the world too. Means let's say pretty soon, I think our grilling season will start, and grills will start to come back again on the patio. So we were talking with another grill manufacturer, and they are talking about a service where every year I have to go out and clear off all the cobwebs, and then go and fill my propane tank, and then clean the grill and just get ready for my spring season. They will do exactly the same thing. They will take care of everything, and they will just bring a nice, depends on what your 4 burners, 5 burners, 6 burners, they will just drop a brand new completely working ones on your patio, and they will monitor it and they will refill it, and at the end of the season no need to winterize or close
Come
or
and get it.
come and take it away. And it's like, it just makes, somehow it makes sense. I mean, it will not there for every persona, but it really makes sense when space is a premium, or you don't want to get hassled by things, or
I think it starts with a change in mindset. We are, I'll speak for myself, part of a generation where ownership, right? I wanted to own the thing. I wanted to go buy it. I wanted it to be mine. I want to be the only one that uses it. I'm not sure that's the way younger people think today, right? They want what they want when they want it, and when they don't want it, they don't want it. And so I think there's lots of things that are going to move to service models. And again, I see no major barrier in this product fitting that eventually.
and you're right, means 20 years ago, not everybody had a service of lawn mowers coming in and mowing their lawns for them, or snow pushing services. But now in the last 2 decades, it's a common practice. It's not that you're doing something completely new. You know you're paying a little bit more, but you're paying for more time, more convenience, where you can spend time with your kids and let's say do another flower garden or a patch or something. So it's already happening in other nearby areas. Why not in the world of tires too? I think I do not know whether Cooper does tires for airline industry, but the airline
No,
industry, I think what they are also doing is they are charging, not charging. The business model there is they charge for every airline landing a fee as such. So it depends on the tire service provider. They will take care of the maintenance, the scheduling, the tires, everything. And every airline that lands successfully, they will get their meter goes with the landings of the airline. So, and on time and all those things, versus looking at this commodity elements of we want to buy tires and then reclaim the tires as such. So you're right. It's how it helps the entire system rather than just looking at the component level as such will be the main thing. I know we are coming towards a little bit towards the end of this. Let me try to take some questions as such. No, Jason, I am not lazy. Uh, about Peter Kenfield, how do you see the future of airless tires?
yeah, non-pneumatic tires. You see, I mean, you see it from time to time. It's the kind of thing that shows up at CES and in other forums. Um, Very interesting. I think again, it depends on the application, right? So you have in off-highway and construction equipment. Some of this stuff's been around for a while. For passenger cars, you know, I sometimes struggle with the concept that, you know, air is free, as I like to say, right? And it serves a great purpose. And when the tire is on the wheel and at pressure, air is serving a very, very important functional role. And the idea of getting rid of that in order to go to non-pneumatic, and again, lots of concepts are out there. People have demonstrated the viability of it. So I could see it coming. Will it be mass market? Ask yourself today, even for, you know, what are called run flat tires. Not really, didn't have been around for a while, at least in this market, other than I think BMW, I think might offer them as an option package. It's not a very common feature, right? And part of the reason why, and it's getting better, is the comfort on those tires has not been met the expectations of consumers. So, and again, the reality is that you don't run around flat. They probably give you about 50 miles of extended mobility. So if you were to get a flat on the highway at night, go back to the same reason I put snow tires on my daughter's car. If she was to get a flat at 11 o'clock at night, would I want her to be able to limp off the highway and get to a place that's safe to call for help or have to deal with the problem on the side of the road? Absolutely, I would pay for that premium in the product. And so I think that, the obvious benefit that a non-pneumatic tire offers is you can't get a flat. Other things can happen for sure, depending on the rest of the design. But I think that if you look at run flats as a proxy, they've had some challenges with what I would call mass adoption. That may change in the future, but I do not see a step function, personally, do not see it, where people are going to move from pneumatic to non-pneumatic. And then I'll go back to where I started, which was the industrialization process, right? So it's a very different industrialization process to make a non-pneumatic versus a conventional tire today. So you got a lot of capital in place to make conventional product that can be, quickly made obsolete if the right technology comes along and we develop products that ultimately meet the expectations of the consumer. But in order to sell new technologies, you got to remember people got to want it. You're not going to get past 5, maybe 10% early adoption, but you're not going to get that 15, 20% tipping point unless you're really, really delivering on the performance and the feature and benefit that the consumer wants. And to date, there just hasn't been a commercial product for non-pneumatic, so the experiment hasn't been run yet.
It is no fascinating when it's like tires can mean and mean a lot. I'm going to go with another question that's from Pete Montero. It's a little bit longer question. Let's see at least the first half of it. Is it a given that trade-offs will exist as we push harder towards the efficiency, the low rolling resistance, with things like ride comfort, noise, and performance being a necessary sacrifice?
Yeah, everything's a trade-off, right? Everything in product development and design, from a functional standpoint, you're always trying to find what's the right optimization. But you're absolutely right. You are usually trading. So the question is, for the given segment, what are the acceptable trade-offs for the end consumer? So somebody who's buying tires for an all-terrain application has a different set of expectations for comfort versus somebody who might be buying tires for a family SUV. And especially as we move into this world of electrified powertrain, where rolling resistance is just going to be so important, right? Because it's so connected to the promise of the battery range. And while we still have a lot of people with range anxiety, you just cannot sacrifice that as a result of what the tire is delivering. So that is going to cause some challenges. Electric vehicles also very quiet, right? So where the initial technology has gone is to embed foam, because in the absence of the engine, the tire is actually pretty noisy. So the in-cabin noise from a tire is unacceptable. So what has been kind of generation 1 solution is to adhere foam on the inside of the tire and disrupt those sound waves. Where this could go and where it's likely to go is something that's a more material-based, a tread design, something that impacts the noise in a way that doesn't cause you to have to add this extra industrial step and cost of adding the foam. And if you really get out there, you could use active noise cancellation in the cabin, the same way your Bose headphones cancel noise. Could I selectively dial out and create counter waves to cancel the noise in cabin that's coming from the tire? In principle, I see no reason why not. So lots of interesting things from a technology and innovation and a material science standpoint in front of us.
You're right.
Like I said before, until we're all moving around in drones, people are going to need tires.
You're right there, and it is so fascinatingly complex that it's not that simple and easy. Because as you said, if you take the main noise maker, the engine, out of the context, now suddenly everybody's looking at you like, how do you reduce the noise from over there? And suddenly a big challenge is dropped into your lap, and then you just start making appropriate elements for them. Then again, trading off between more mass for foam or more compounds. When you mention around 120, I don't know, components or let's say chemicals into a tire. That's just bonkers. Like, wow,
Yes.
there must be so many things to stabilize and destabilize and all those things. This thing, it's just a single, let's say, compound, but a compound is a compound. It's mixing of so many things. That's pretty amazing. I know we are almost towards the end. We cannot do more questions. Maybe at least one more question from Jason. Uh, are there any government subsidies that can help with research for future materials? Any crowdsourcing components to the development of innovation in this industry? If you are,
Yeah, absolutely. I mean, again, it depends on partnering with universities, or I mean, here in Michigan, there is a tremendous amount through Michigan Economic Development, a lot of money available for startups. It's people want to innovate, and luckily governments and universities support this collaboration between industry and building out ecosystems that involve universities. So yeah, there's an enormous amount of money, but it's like everything else. It has to, where does it fit in your priorities, right? It takes a lot of time and effort to write a good grant, and sometimes is that the right approach to fund high risk activity, really drive the front end of innovation? Sometimes that's the right answer, and sometimes it's to, as Thomas was saying before, you got to work with other industrial partners, and then you can cost share the investment and share in the rewards by properly parsing the foreground IP. So lots of different models, but yeah, there's no shortage of support of R&D dollars.
okay. And even anybody finds any other links, you can drop them in the chat. Maybe one last point or question from Clayvon. First of all, Clayvon says thanks, especially because great points coming from an owner of, he owns a hybrid, a performance car, and I know this, he also owns an 18-wheeler truck. He's a good crazy designer over here. Like, who keeps an 18-wheeler on his driveway? How long is your driveway, Clayvon? So I think his question is thoughts on preventing tractor trailer tires from causing extensive damage with blowouts to the vehicles as well as other drivers. Would there be run flat versions for those vehicles?
I mean, there could be. There's nothing, nothing from a design standpoint in preventing it. But remember, it's the decisions that are made on those commercial trucks are all based on total cost of ownership and the value to their cost per mile. And so unless somebody could design, a technical solution here that was at least cost competitive with what the current offering is, it would be a hard sell, right? Because you could develop the technology, but if it's too expensive, there'll be very, very limited adoption. And the challenge, I have great empathy for this. I mean, we all see these chunks of tires on the roads coming from trucks. If you live in the greater Detroit area and you run up and down I-94, there's a lot of trucks. So it's a very, very interesting problem to solve. The challenge is the economics.
Awesome. I think we're almost there, but maybe one question as such before going out. Any wisdom words of nuggets to our audience about? You have an amazing career. Means I have followed you for a decent amount of time. What made you as an expert, and what would be some of those attributes you want to share to, let's say, the younger crowd of our audience to one day be what Ben is?
I don't know that should be the question, but I understand the question. Stay curious. Wake up every day curious. And the cliche about learn some, constant, be a learning animal. Always be learning, either through your day job or whoever you're interacting with. Those two things are very powerful, right? And in today's world where we all have access to so much information, there's almost no excuse for not continuously learning. But what you find is when you feed that beast, right, and you have that curiosity to keep learning, and you're waking up every day wondering, hey, how could I solve this? Or I saw this problem. I wonder if there's a better way to solve it. What you'll find is there's a lot of other people out there to interact with, and start cross-pollinating, right? Because the best things happen when many ideas come together, and all of a sudden you have a system level solution. Those are usually the most interesting places where innovation is really having an impact. And as a chemistry material person, I would say that look for interfaces, right? Look for where one thing is bumping up against something else, right? Because usually all the interesting problem statements are at interfaces. And so that's my basic philosophy is stay very hungry for knowledge, stay very, very curious, and interact with other people because that's what it's all about.
I love that. What you said is absolutely true. Innovation happens at the friction of boundaries, and that's where the interfaces are, and trying to unravel those elements and try to see what other things can happen and makes everybody and anybody smarter. So once again, Ben, I thank you from bottom of my heart to just coming over here and just engaging us about an everyday object, which is a part of our existence, at least for the next foreseeable future. So thank you again. Feel free to be on the stage. Feel free
Sure.
to just unmute and unvideo yourself. And
Okay. Well, again, I thank you for the invitation. I thank both to you and Lene for helping me get my presentation together. And I'm curious to hear presenter number 3. So I'm going to go on mute and stop my video.
awesome. Thank you. Once again, gentlemen and ladies, that was Ben, a literal PhD in chemistry from Yale, talking about this amazing world of this everyday donut, right? Means not the donuts that we eat, but the donuts that we roll on, and the way they are a part of the entire circular economy. Means I really had means I had a decent idea, but about this microplastics and what we are doing for the last 100 years, and how fine these shavings are going into our salmon streams and eventually finding a place into our produce aisles. But not just about tires, but plenty of things we are doing, I would say, as a humanity, which we have to be really cognizant of how it might affect, not right now, not 20 years, not 50 years. I think as Isaac Asimov, one of the amazing futurists, always said, think about 500 years down, 500 years. And that sounds sometimes childish for somebody to think about that, but we never know what we are doing right now till we can see on the hindsight what needs to be done. Or I think as the local Native Americans say, the N7 generation, think about the 7th generation down to see about what are we doing. It might be changing the landscape around us, changing the building materials around us. So somehow I think even though we are here trying to solve problems of here and now, trying to look at, let's say, just our myopic world, it always, I would say, would always be meaningful to step out a little bit, as Ben was saying, always be thirsty for knowledge and also be curious and cross-pollinate and try to be open at the interfaces, open at the intersections between different overlaps and boundaries as such. And that's where true innovation and invention can happen.